Good morning, students. Okay, we have arrived at our second last chapter. Okay, it's linear regression. Okay, this is, I think, this is first new for you. Okay, so let us start our chapter. What is regression means? Okay, in the statistical methods which help us to estimate or predict the unknown value of one variable from the known variable of the related variable is called regression. So you have there is unknown and known variable, that is similarly as dependent and independent variables. So the unknown variable, the value of the unknown variable can be estimated from the known value of the related variable. That is regression. That statistical method is regression. Okay, that is, the word regression means the act of returning or going back. That is, the he has observed, it was first used by Francis Galton, which is in the 19th century. Okay, he has to describe the relationship between the heights of fathers and heights of son. For that, he observed that tall fathers have tall sons, short fathers have short sons. So the average height of the tall fathers, which is less than that of fathers, and the average height of short sons are greater than that of fathers. So this tendency to regress to or go back towards the average of population, which was described him as regression. That is, the line describing this tendency, which is called the regression line. Okay, which means the father, okay, the tall father has tall sons, but the average height of sons of tall fathers is less than that of fathers. Okay, so that is a regression, which is the tendency to regress back, or which is go back towards the average which of the population. That is regression. And that line, or the tendency to which we regress back, but that is the regression line. And also the line which gives best possible estimates of values of one variable, okay, which is given for other variable, that is the line of best fit. Okay, and that is the new terms you have to be. Okay, so regression is it helps to predict or estimate the value of one variable or the independent variable from the independent variable. Okay, that is a regression. Okay, that the line for the tendency is the regression line, and the line of best, which is the best possible estimates of the value of one variable, okay, for given for the of the other variable. That's the line of best fit. And the line of regression of y on x as the form y is equal to mx plus c. That is mx plus c. That is the line of regression of y on x, and x on y is x is equal to my plus c. And similarly for quadratic equation, it is y is equal to a plus bx plus cx square. Okay. Determining the line of regression means determining the line of best fit. Okay. Yes. And the methods of curve fitting. Method of least squares. That is the one. And if we have given the data x1, y1, x2, y2, etc., xn, yn, and we plot a scatter diagram. Look at that figure. Yes, that x1, y1, x2, y2, x3, y3, and etc. x and yn is scattered there. That points are scattered here and there. Okay, and then we have to draw a smooth curve by eye approximating to by eye. By eye means just draw that. And this is called the freehand method of curve fitting. Okay, we are going to fit that. So we have just drawing that curve, and then we have just simply drawing a line. Through a line we have just relating that. Okay, and this method has the disadvantage that it depends on individual judgment. Okay, so this is our choice. If we draw the line, how will you have to draw the straight line, how will you have to mark or join together the points? This is our choice. So according to individual, it changes. Okay, it changes according to our judgment. So to that, the vertical distances d1, d2, etc. dn, which can be drawn from each point x1, x1, y1, etc. x and yn to the curve. So these distances will be positive or negative according to whether the points are below or above. So we have, that always, the distance does not be negative. So for that reason, we have just taking these squares of these values and then considering their sum. That is d1 square plus d2 square plus etc. plus dn square. That is the method of least square. That is a measure of the goodness fit of the curve to be determined, or of the data is provided by the quantity. If this is small, it is good. If it is large, fit is bad. Okay, that is by definition. That is, of all curves approximating a given set of data, that is data points of curve, which having the property that's d1 square plus d2 square plus etc. dn square is a minimum, then it is a best fitting curve. Okay, this is the best fitting curve. Okay, this is the method of squares, least squares. And the curve having this property, which is said to fit the data in the least square sense, that is the least square curve. Okay, we have just drawing that curve and the straight lines d1, d2, etc. dn, and the squares, the sum of the squares is least in this sense, then it is the least curve square, which is the regression curve. Okay, so regression curve. And the line having this property is called least square line, or if it is a parabola, there should be not, it should be a line like that. Okay, so it have been a curve which is a parabola, then it is a least square parabola. Okay, so that is regression curve. And what is linear regression? Okay, so, and line of best fit. Okay, linear regression, line of regression, that is the line of best fit. So in the particular case, when this best fitting, which is a straight line, it is a line of best fit or a line of regression. So we have studied that, we have just know that the curve or the line should not be a straight line, it may be a parabola with the property. So if the line is straight, then it is line of regression, and the regression is said to be linear. That is, a line of regression is a straight line which gives the best fit in the least square sense to the given data. Okay, that is line of regression. And the regression of y on x, that is y is equal to mx plus c. That is the equation of that line. Y is equal to mx plus c. And regression of x on y is x is equal to my plus c. This is the regression. Okay, I think all of you understood the regression, meaning of regression. And if the line of regression is this, okay, and the squares of deviation parallel to the x-axis, parallel to the axis of y is minimized, this is the line of regression of y on x. Y on x. And the regression of y on x is this, and the equation is y is equal to a plus bx. And the slope of the line b is the slope of the line. You know, y is equal to mx plus c is the equation of a line, then m is the slope. So if we take y is equal to a plus bx, b is the slope of the line. So it is the regression coefficient. So slope of the line is the regression coefficient, and it shows that y changes b times as fast as x. Okay, and that is, we can symbolically represent the regression coefficient as y on x as byx. So it is the regression coefficient of y on x, byx, and regression coefficient of x on y is bxy. Okay, So the y is equal to mx plus c. It is the straight line equation, which is the line of regression and regression of y on x. And then m is the slope. And if we take the equation y is equal to a plus bx. Okay, so b is the slope. So the slope of the line is the regression coefficient and it is byx. And that is the byx and bxy, which is important. Okay, so in this chapter we have to be just familiarized with these concepts and names, and some equations has to be remembered. No need to study the proof. Okay, according to that equation there is some problems. That's all for this chapter. Okay, and so byx and bxy. So it is clear, regression coefficient. So this is symbolically given. Okay, regression of y on x, algebraic form of the line regression is y is equal to mx plus c, and the coefficient of x is the slope, which is the regression coefficient, that is myx. Similarly, mxy. Okay, and next is some remarks for that. The point of intersection of two lines of regression. How will you find it? So both regression equation which have passed through the point x dash x bar y bar, then x bar is the mean of x series and y bar is the mean of y series. So when we have calculating x bar and y bar, that is a point through the regression passes through, that is the mean value. Mean is the point. Okay, and regression lines and the correlation, that is, if two lines of regression when plotted on a graph paper, when it is coincide, there is a perfect correlation between the two series, and the greater the angle between the line, the lesser is the correlation between the two series. And if they cut each other at right angles, there is no correlation, and evidently the two regression lines cannot be parallel. Okay, that are the remarks, and this is given. Perfect positive relation, that is x on y and y on x, which is coinciding. Perfect negative correlation is r is equal to plus 1. R means the regression. Okay, and that is given. Negative is given, and high positive correlation, these two coincides, and high negative, low degree positive, high degree positive. These are some symbolic representation. Okay, graphical representation. And this also, there is no correlation. If they are perpendicular, there is no correlation. Okay, yes. So these are the graphs for correlation. And yes, next is the general equation of regression lines. So the general equation for regression lines is sigma y is equal to nc plus m into sigma x. Sigma xy is equal to c into sigma x plus m into sigma x square, which is the normal equations. Okay, so here x1 x2 we have taking the straight line, which is the line of regression, y is equal to mx plus c, and x1 y1 x2 etc. x and y and be the n pairs of observation of two variables x and y. Okay, and the line is y is equal to mx plus c. Then for the observed value x1 of x, we get the two values y, which is 1 y1, and the other is mx1 plus c. Okay, first coordinate is y1 and next is the line mx1 plus c. Similarly, next one, and the difference is mx1 plus c minus y1, that is the d1. Similarly, d2 etc. dn, and their squares, we have taken their squares, that is the square method, least square method. So mx1 plus c minus y1 the whole square plus etc. plus mxn plus c minus yn the whole square, so which is to be minimum. Okay, and that is the sum which is given here. Okay, this is the normal equations, and the line of regression, the equations are byx is equal to, this is the most important one. Okay, you have to by heart this is the equation. You have to just study the equation, no need to go through the deep. Okay, just study, and the notations. What does x means, y means that, and what is m, like that. Sigma n, what is sigma n, x means, sigma y means that, you have to remember. Okay, you have to just remember this equation, that is the important one. So since the coefficient of x is the equation y is equal to mx plus c, we can represent the regression coefficient of y as myx, that is myx is equal to sigma xy minus sigma x into sigma y by n whole divided by sigma x square minus sigma x the whole square by n. Okay, that is the equation. And or bx by x is, okay, the sigma xy is here, sigma xy is c into sigma x plus m sigma x square, and sigma y is nc plus m sigma x. So substituting that, so we get myx as this, n into sigma xy minus sigma x into sigma y by n into sigma x square minus sigma x the whole square. So this is the equation for the regression of x on y. Similarly for byx, regression of y on, the y on x is byx, and the regression of x on y is bxy. Okay, that is given. Okay, so these are the two important equations. And which is next is the, if the deviations of variables are arithmetic means of the series, that is x bar y bar, we have told that in the remark. Okay, and that is dx is x minus x bar, dy is y minus y bar, which is the deviation of the variables x and y from the arithmetic mean. X bar and y bar are the arithmetic mean. So what is byx and what is bxy and bxy, that is sigma dx dy by n into sigma x square, and bxy is sigma dx dy by n into sigma y square. Okay, what is sigma x and sigma y, which is sigma x by n, sigma x the whole square by n. Okay, that is. So this is the important equations. And next is the equations for substituting the value of byx in this, that is regression of y on x and regression of x on y. This is the most important equation. Y minus y bar is equal to sigma dx dy by sigma n into sigma x square into x minus x dash, and x minus x bar is equal to sigma dx dy by n into sigma y x square by into y minus y bar. Okay, this is the main important equations. And next is some properties of regression coefficients. Okay, that is you need not need to study the proof. Okay, just this equations, that's all. Correlation coefficient is the geometric mean between the regression coefficient. What is the correlation coefficient? Correlation coefficient is R. That is correlation coefficient is R. That is the geometric mean. You have studied geometric mean. That is the mean, which is geometric mean between the regression coefficients. Okay, so that is R is equal to sigma dx dy by n into sigma x into sigma y. That is, which is the product moment formula due to Carl Pearson. Okay, and the modified R is, okay, this is just a property. Okay, and sigma dx dy minus sigma dx into sigma dy by n whole divided by root of sigma dx square minus sigma dx the whole square by n into sigma dy square minus sigma dy the whole square by n. Okay, this is the first property. And second is, if one of the regression coefficient is greater than unity, which is numerically given, then the other is less than unity. And the third is, the arithmetic mean of regression coefficient is greater than the correlation coefficient. That is, byx plus bxy by 2 is greater than R. R is the correlation coefficient. Okay. And the fourth property is, the correlation coefficient and the two regression coefficients have the same sign. Okay, the sign is always same. Okay, this is the last property. And now the summary. Many equations you have studied. Okay, for not to confuse it, please study this table. Okay, the table is very easy, and the regression equations, normal equations, regression coefficients, when it is deviation we take as mean, and which is assumed if we have assuming the mean as given, and the original values have been used, that is the next one, and the last one is the two lines of regression which intersects x bar y bar. What is the coefficient correlation coefficient is r, which or rho of xy, which is root of byx into bxy. Okay, that is the correlation coefficients equation. Okay, yes, so this is the most important table you have to study. This is a summary of this chapter, and the exercises. According to this, you have to determine the lines, straight line which is given. The point is given. Draw the points, this curve, and then d1, d2, etc. So that is next given data also. And you have to find the regression coefficient byx and bxy. The third question, equation. The lines are given. Okay, so substitute the equations is, you know, the how to find the equation for byx and bxy. Substitute the given values, you will get the answer. Okay, so this is just linear regression, introduction to linear regression. If you just study that equation, what do you mean by the definitions also, then you can clearly know. So this is the small chapter for linear regression. Okay, I hope all of you understood the chapter. This is just definitions and equations. When you have remember the equation, then you will easy to follow the questions. Okay, so this is all for today's class. I hope all of you understood. The workout problems are there in your textbooks, so please do that and do these exercise problems also. Okay, then thank you students. Have a nice day.